Hi everyone, in this video we are going to see how to find the equations of the family of circles that go through the points of intersection of two given circles. Let's suppose we have two circles like this whose equations have been provided. The left hand side expression of the first circle's equation is denoted by S sub 1 and the left hand side expression of the equation of the second circle is denoted by S sub 2. Let's suppose the points of intersection of these two circles are P and Q, and let's suppose their coordinates are like this. Now, how many circles can we draw through the points P and Q? Well, let me draw a few, then you will realize how many we can draw. Actually, I have drawn quite a few. They all go through the points P and Q, and from here you can clearly imagine that we can actually draw infinite number of circles going through the points P and Q. That means we should be able to come up with a general equation for all these circles that will be going through the points P and Q. That means they will satisfy the coordinates of the points P and Q. So let's get started with the derivation. If we think about our two original circles, the solid yellow circle and the solid light green circle, since they go through the points P and Q, P's coordinates would satisfy the equations of both circles. Similarly, Q's coordinates also should satisfy the equations of both circles. Now here I have noted the equation of the first circle satisfied by the coordinates of P and Q, and then I have noted the equation of the second circle satisfied by the coordinates of P and Q. Next I am going to assign a number to each of these equations, and then I am going to assign a name to the left hand side expression of each of the last four equations here. S sub 1p indicates that it's the left hand side expression of the equation of the first circle satisfied by the coordinates of the point P. Similarly, S sub 1q indicates that it is the left hand side expression of the equation of the first circle satisfied by the coordinates of the point Q. S sub 2p indicates that it's the left hand side expression of the equation of the second circle satisfied by the coordinates of point P, and S sub 2q indicates that it's the left hand side expression of the equation of the second circle satisfied by the coordinates of the point Q. And from here we have to try and somehow come up with a general equation for the family of circles that will be going through the points P and Q. Now I am going to follow a step-by-step approach. So the first operation that I am going to do is I am going to add the equation number 3 with equation number 5, and let's see what happens. If we add equation number 3 with equation number 5, we are going to get an equation like this. And now let's divide both sides of this equation by a positive 2 so that the coefficients of the x squared term and the y squared term become 1, and then our equation would look like this. And if we rewrite the equation, our equation could look like this. And here obviously g sub 3 is equal to g sub 1 plus g sub 2 over 2, f sub 3 is equal to f sub 1 plus f sub 2 over 2, and c sub 3 is equal to c sub 1 plus c sub 2 over 2. Now if you carefully look at this equation, this is looking like the equation of a circle whose center is located at negative g sub 3, negative f sub 3, and this circle satisfies the coordinates of the point P. So I have made a note here that this equation that we just derived, it is nothing but the equation of a new circle passing through the point P. I am going to do a similar operation again. Next I am going to add equation number 4 and equation number 6, and let's see what happens. Following the same steps, here we find that this also gives us the equation of the same new circle. However, it is now satisfying the coordinates of the point Q. That means by adding equation number 4 and 6, we are able to come up with the equation of the same new circle which also satisfies the coordinates of point Q. That means it goes through the point Q as well. Previously we saw that the new circle goes through the point P, and here we see the same new circle also goes through the point Q. And what would be the general equation of this new circle? Well, it will be x squared plus y squared plus 2 g sub 3x plus 2 f sub 3y plus c sub 3 equals 0. Next I am going to try a similar operation where I am going to add equation number 3 with k times equation number 5. K is a real number, so equation number 3 plus k times equation number 5, and let's see what happens. By doing that, we get a new equation again which looks like x sub 1 squared plus y sub 1 squared plus 2 g sub 4 x sub 1 plus 2 f sub 4 y sub 1 plus c sub 4 equals 0. And if you carefully look at this equation, this is obviously looking like the equation of a circle. So this is another brand new circle whose center is located at negative g sub 4, negative f sub 4. And of course this circle passes through the point P because the equation of this circle is satisfied by the coordinates of the point P. So I have made a note here that we have found the equation of another new circle that also passes through the point P. And I'm going to do a similar operation with the equation number 4 and 6. So it will be equation number 4 plus k times equation number 6. And if we do that operation, let's see what happens. Here again we find the same new equation. The only difference is that this time the equation also satisfied by the coordinates of the point Q. So essentially it's the equation of the same new circle that we found in the previous step. The only difference is that looks like the circle also satisfies the coordinates of the point Q. That means we have been able to find the equation of a circle that passes through the points P and Q. And in this equation you can clearly see that we have a variable which is the k, that's like any real number, and using that variable we should be able to now formalize the general equation of the set of circles that go through the points P and Q. So the general equation would kind of look like this. We can write it as x squared plus y squared plus 2 g sub 4 x plus 2 f sub 4 y plus c sub 4 equals 0. And I have made a note of the values of g sub 4, f sub 4 and c sub 4. And how did we obtain this equation? Well, we simply did s sub 1 plus k times s sub 2, and that is how we came up with this equation. So that is actually the general equation of the family of circles passing through the points of intersection of the two original circles. Now we need to discuss about something interesting here. If you look at the denominator of g sub 4 or f sub 4 or c sub 4, you will see that we have something like 1 plus k, where k is any real number. Now the denominator can never be 0, right? So 1 plus k cannot be 0. That means k can never be negative 1. Now if you are thinking, well, what will happen if we take k as negative 1? Look at this part of the equation that we derived in the last step. I have used a red box there. If you look at that part of the equation, you will realize that when k is taken as negative 1, then the x squared term and the y squared term, those two terms will disappear. The coefficient of x sub 2 squared becomes 0 and the coefficient of y sub 2 squared also becomes 0. That means it is not the equation of a circle anymore. It becomes the equation of a straight line. It becomes a linear equation. And in that case, what would be that straight line? Well, the straight line is actually the common chord. So by taking negative 1 for the value of k, we are going to obtain not the equation of a new circle, we are actually going to obtain the equation of common chord. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. There we have derived the equation of the common chord, which looks like s sub 1 minus s sub 2 equals 0. So by taking k as negative 1, we are actually going to end up with the equation of the common chord, not the equation of the family of circles. So then for our general equation, we have to note one restriction there, that k can be any real number other than negative 1. So if k is any real number other than negative 1, then s sub 1 plus k times s sub 2 equals 0. This equation actually gives us the equation of the family of circles that will be passing through the points P and Q, which are nothing but the two intersection points of the original circles. I hope the entire derivation made sense. Thank you for watching. See you in the next video.